This is the 3.4 mini lesson starting on page 170. When you save money in a bank savings account, the bank pays you money each year and adds it to your account. This additional money is interest. So that's one of our terms. It's the amount that the bank pays you each year and adds it to your account for using your money. They then pay interest for the money that they borrow from you. An original amount of money in your account is called the principal. So if you go to the bank and you open an account and you go in with $100, let's say, that's your principal. It's what you start off with. Interest is calculated as a percent of the principal. One type of interest is called simple interest. Simple interest is which a fixed percent, it means it stays the same, of the principal. Simple interest is paid over a specific amount of time, either twice a year or once a year, for example. Here's the formula used for simple interest. It's interest is equal to, and you're going to notice this is a capital P, principal times the interest rate times the time. So here they give us an example. Kim deposits $300, so there's my principal, into a savings account at a simple interest rate of 5% per year. We can use the formula to calculate the interest she will have earned at the end of 3 years. So my time is in years, it's at the end of 3 years. So I know interest equals principal times rate times time. We're just substituting in what we know. Principal is 300. The interest is 5%. Remember, changing a percent to a decimal, we take this decimal, we have to move it 2 spaces to the left. So I get 0.05. So that's where they have here. And then the time was 3 years. When we multiply all of that, we get $45. So if Kim puts $300 in the bank for 3 years and doesn't touch it, after 3 years, the bank will give her another $45. So she will have altogether $345. So I'm going to just do a few of these. I'm putting my variables up at the top. So principal, P, times rate, times time, equals the interest. So I'm going to do this first one here. So if I take principal, I'm going to do it off to the side, 425 times my rate as a decimal, 0.07, times 5, that will equal my interest. So I'm going to put this all into my calculator, 425 times 0.07 times the 5 years, and I get 148.75 would be the interest. And this is in money. So someone who puts $425 in the bank for 5 years, and they're told they have a 7% interest rate, they're going to make an additional $148.75. So I think these would be pretty easy to solve for. Here, these three are going to be more difficult, so I'm just going to take one of them. I'm going to try this one. I'm still following my formula because we know how to solve equations. So it's 456 times 6%, 0.06, times my time in years. I don't know it. I'm going to call it T, equals the interest, 109.44. So now I just solve the way I know how to solve. On this side of the equals, I can multiply 456 times 0.06, and I get 27.36 T equals 109.44. Now I'm isolating my variable, so I'm continuing just to solve for T because that's what I'm looking for. I divide by 27.36 to both sides of my equation. Here I will get 1T, and on the other side, if I take 109.44 divided by 27.36, I get 4. So my time would be 4 years. In the same way, when the bank pays you interest, when they use your money, you too sometimes will be paying interest. So this is when you're borrowing money. So it's the same exact formula when you borrow money. So borrowing money from a bank, the amount you borrow is the principal, and then you pay the interest on the money back to the bank. So we're going to complete this table. I'm going to jump down to 3, and I'm going to model 3 and 4. So again, P, I'm going to do this right up here, 1,500 times 7%, 0.07, times 3 years equals my interest. So now I'm going to solve my equation. I can take 1,500 times 0.07 times 3, and I get 315 is interest. So if I borrow from a bank $1,500, if I borrow that money for 3 years at 7% interest, I will be paying the bank back all of this, plus I'm going to need to pay them back this extra amount. Now, if I want to find the principal, I follow the same formula. So I don't know P, but 2% is 0.02, and for 20 years, and I have to pay an additional 7,200. So now we solve this algebraically. I can multiply these two. So when I multiply 0.02 times 20, we get 0.4. So I'm going to put this in the order that makes more sense to me. 0.4p equals 7,200. I'm going to isolate my variable, divide both sides by 0.4. And when I do that, 7,200 divided by 0.4, I get $18,000. So I would have borrowed $18,000 from the bank at 2% interest for 20 years. I would have to pay them an additional $7,200 for allowing me to borrow their money. So this might be for a car or something. That would be a pretty big purchase. Problem 2 gets us into increase and decrease. So you can use percents in different situations. We've used tips, interest, construction problems. We can also use percents to describe a change. A percent increase occurs when the new amount is greater or increases over the original, such as when a store marks up the price they pay for an item in order to make a profit. So a store might buy something for $10, they're going to turn around and sell it to us for $15. So All That Glitters jewelry store marks up its prices so it can maximize its profit. What is the percent increase for each of these items? Use the formula shown to complete the table. Here's the formula for percent increase. It's the amount of increase over the original. So I'm going to look at this first one. So I have to be careful reading my headings. So if I'm going to buy a ring, the cost in dollars to the store was $60, but they're going to sell it to their customers for $90. So this was the original. This is what they're selling it to me for. So the difference is they're marking it up $30. So now I'm going to find my percent increase. It says the amount of increase, they increased it by $30 over the original amount. The original amount was 60. So if you divide 30 divided by 60, you're going to get 0.5, but we want it as a percent, so I need to move the decimal 2 places to the right, and I will get 50%. So that's a 50% increase. I'm going to try one other one. They paid $36, but they're going to sell it to me for $45. So that is a $9 increase. So now I'm using my formula, amount of increase. It increased 9 out of the original 36. So you might already know 9 out of 36 is 1/4, and I know 1/4 is 25%, or you might know it's 0.25. If you don't, we could take 9 divided by 36 to get 0.25. Now I need to change that to a percent. So they marked this up 25%.